Hey, welcome back, guys. Yeah, so far we've been talking about functions, and you've learned quite a lot about functions and how to use function to write um, reusable pieces of code that you can invoke whenever you want. Okay, so in the last video, we started talking about function expressions. So before now, everything we've talked about in functions is just function declaration. So we declare a function and we can pretty much call it anywhere. Yeah, so let me show you something. Um, if I say, if I want to call this function now, for instance, all I just need to do is to do sum, and then I follow with brackets, and then I save, and then so here it is. Open this, and cool. Now, of course, it doesn't return anything to the console until now. This function is expecting an array, so I need to pass an array of numbers. So it's going to sum all the numbers in that array. I save that, and then nothing in the console yet, so I can do console.log, and then I pass this, then I save. So I got 200. That is the sum of all the numbers in this array, which is basically what this function is doing. It returns the sum. It sums up um, all the numbers in the array you pass to it using a for loop, and then it returns the sum. Right? That's what this number is doing. So every time you want to sum an array, all you need to do is just call this function and pass the array. The array doesn't have to always be the same. The fact that we have a parameter here means that we can call this function anytime, pass an argument, and it will do exactly the same thing. Now this is function declaration. If we want to convert this into a function expression um, by assigning it as a value to a variable, all we need to do is to say const. Now um, this, the name is gonna go, so I'll say const sum, and then I put assignment operator. You see, so see that this function doesn't have a name anymore, right? It doesn't have a name anymore. It's just a function expression, and then we assign it as the value of this sum variable. So if we want to call this function, we will do the same thing. This time around, we are referencing the name, or the name of the function to which we assigned the variable. So if we save this and check our console, it is still the same thing. Right, now notice here that this function doesn't have a name per se. We just have a variable name, and then so this is something you can also call anonymous function. Right, it's anonymous because it doesn't have a name. Right, so um, another difference I want to show you between function expression and function declaration is the fact that um, variables, you cannot call a variable before it is declared. For instance, if I try to call this function here like this, it's not going to work. Actually, it's going to throw an error. It says uncaught reference error, cannot access sum before initialization, because this sum basically is a variable. It's not a function name, so it's a variable, and because we are trying to access it on line 88 while we actually defined it on line 90, it's not going to work, right? But if this was a function declaration, we could do this and it would work. So let me get rid of this, and then check this and go back, and it works. It works. So just wanted to show you that. So use function declarations where you can, and as we move along, I'm going to show you when to use function expression and when to use function declaration, I don't really want to go into deep details of this. I wanted to just show you how these things work. I mean, you can use function expressions or you can use function declaration, and also so that you know what I mean when you hear the terminology, right? Okay, so what I want to do in this video really is to introduce you to another concept in JavaScript. So far, I think we've actually covered all the basics of JavaScript. I mean, and all the basics of programming generally. So the things that JavaScript shares in common with other programming languages, we've pretty much covered them, starting from variables to functions. We talked about variables, we talked about data types, we talked about how to write conditional statements, we talked about loops, we talked about operators. So those are really, really basic programming concepts, and they are transferable to even when you want to learn other programming languages. The syntax may be different for other programming languages, but those concepts are basically the same. Okay, so congratulations. Now, what we want to do is to focus more on something that is JavaScript specific, and we want to talk about the built-in methods in JavaScript. So, these built-in methods we want to talk about are date. So, actually, mat and date objects. So, I want to talk about built-in objects. So we're going to start with mat. So mat is basically a set of object that allows you to, you know, perform mathematical calculations in JavaScript. So there are methods that already exist within the language. You don't have to write your own logic. All you need to do is to invoke them and use them. So, I mean, there are quite a lot of them, but I have prepared a cheat sheet for you here. I'm going to add a link to this cheat sheet and as part of the description to this video. But basically, these objects are in different categories. So first you have the constants, right? So the constants, so you have the Euler's number, math.e, you have natural logarithm of 2. So these are constants. And then of course there is pi. So ratio of circle circumference to its diameter. So you, of course, you know you can use this when you want to calculate things like when you want to do geometry that is relating to circles, like area of circle and all that. Okay, so then there are methods. So these are properties and they are constant, and then there are methods, and these are the ones you likely work with most of the time. So there are methods in different categories under methods. So there are rounding methods. So these are methods that you can use to round numbers. So math.round will basically round number to the nearest integer. Now there's math.floor. So we're going to see this. We're going to see this in action. There's math.floor, which basically rounds down to the nearest. It will round it down. This will round it up. Math.ceil will round it up, and then math.trunc simply removes the fractional part of a number. So you can see. So let's just see this in action. So first we have math. So like we said, this is an inbuilt object. We didn't have to define it. We didn't have to define an object or create an object called math. It's already built into the language. So we can say, you can see this the moment I do math dot, it begins to give me all these methods and properties. Okay, so let's start with math dot round. And so remember that you use math.round basically to round number to the nearest integer. So let's say 5.9. Okay, so actually let me console log this. I know it's, let me just CLG. So console.log, then I save. So what do you think this is going to be? Gives us 6. That's the nearest whole number. So you see, as I said, it rounds numbers to the nearest integers. Okay, so of course, if I do 9.4, it's going to be 5 because 5 is the nearest whole number, right? That's what math.round does. Now, if I want to round down to the nearest integer, round down, it means irrespective of whether this is 4 or 9, it will always round it down to 4. So I can do math.floor. Okay, so it gives me 5, and then even if I did 0.9, which should be 6 if it was math.round, it will still give me 5. Okay, because it doesn't really care about the fractional part, it just brings it down to 5. Okay, of course, if you want it to go to the upper limit, you can do math.ceil. So this would basically go to the next higher integer. Okay, respective of what the fractional part is. So 5.9 gives me 6. The same way 5.1 will still give me 6, right? And then so after the rounding methods, there's, okay, let's see math.trunc, which will basically remove so let's do this. It will basically remove the fractional part of the number and return the integer. So you check this 5, if I do 5.5, still gives me 5. Even if I did 5.9, still gives me 5. Now at first you might think that this is the same as math.floor, because either way it basically just returns the next lower integer, right? But you're going to see the difference when you deal with negative numbers. So let's say, for instance, I put a minus in front of this, right? And I do math.trunc. Okay, actually, let's, okay, so math.trunc, it will simply just remove the fractional part. Okay, but if this was math.floor, what do you think this is going to be? Remember, math.floor will round down. All right, it will round down. So the next the next lower integer is going to be -6. You see, so because when it's a negative number, the higher the value, or the, the higher the integer, the lower the value. Okay, so I hope that makes sense. Now, the other set of operators are, you know, what you call random number generation. So you have math.random that you can basically use to, generate random numbers. So if you just do, for instance, math.random, okay, and you don't pass anything, what this is going to do is it's going to generate random numbers between 0 and 1. And so if you look at this, you see, generates random number between 0 and 1. So if I rerun this, it's going to generate another set of random numbers. If I run this, another one. If I run this, another one. Okay, so what if you want to generate random number between 1 and, you don't want it to be fractional, so you can just multiply this by 10. Excuse me. Okay, so if I run this again, it says 6 points. So what if I just want to generate random integers? What do you think? I mean, I can use any of those rounding rounding methods we saw earlier. So I can do math dot floor. That's what I want to do, and then I put math dot random, and then each time it gives me a random integer. You can see 8, 7 2 2 8 8 2. Is this really generating random numbers? um 5, actually it's random. 6 7 9. So I mean it's generating random numbers between 0 and 10. So, and we just saw that we um, can combine multiple methods. So I mean this is one of the most widely used or most commonly used math objects, that's math.random. Okay, you can use it to build like number guessing game, or any of those things that you can use to generate numbers. Okay, so I mean, there are other arithmetic methods. So math.abs, this is going to take the value. It's going to return the absolute value of a number. So when you have -7, for instance, math.abs is going to it's going to return the absolute value, which is going to be 7. Okay, that's the value of a number without the sign. Okay, so there is math.power, which basically returns the power of a number. So it takes the first number and return the second is going to be the power. So if I do math.power and I pass two parameters, 2 and 3, it's going to return 2 raised to power 3, which gives you 8. Okay, so and I mean you can try this out and see how this works. Now what's important is how do we really use all of this? I mean, you can go through the rest. There are trigonometric methods and there are minimum, maximum. So you can use math.max to get the maximum of numbers. So for instance, if I have an array, or if I have a set of numbers, I can get the minimum of that number using math.min, like the minimum. So let's say I have a set of numbers. Um, so math.min, and then I pass set of numbers separated by commas, then I save. So this is going to return 1 because 1 is the minimum of this set. And if I check here, um, hold on, actually I should do console.log. Okay, so put it here. Cool, it returns 1. All right, so that's how you do that. Now I was going to show you how we actually use this. So for instance, random integer between 1 and 100. If you want to generate a random number between um, between 1 and 100, so you can use math.random combined with math.floor, and of course multiplying by 100 means you want it to go from 1 to 100. When we did 1 to 10, we multiplied by 10, and then you have to add +1 to actually include 10. When we did math.random and then we did multiplied by 10, it's going to generate between 0 and 9, actually between 1 and 9. But when we add this, it includes the upper limit. Okay, so so if we did okay, let's take this back. All we need to do here is to add +1 and then multiply this by 100. Cool. So it's gonna give us more random numbers. Okay, so, and if we save this again, refresh again, refresh again, refresh again, so it just keeps giving us random numbers. And there are really interesting, cool, interesting things we can do with this math.random. Like so many cool and useful features we can build. But of course, we're gonna take it one step at a time. So you can calculate the area of a circle, math.pi times math.power. Basically, circle is pi r squared. That's the area of a circle. So math.pi gives you 3.14, and then math.power. So math.pi is one of the first set of um, um, properties we saw, which are constants. And then we use the method, the power method, to get it. So remember the power method where it takes the first argument and then raises it to the power of the second argument. So this is basically saying reduce raised to power 2, that's r squared. And then you can also convert degrees to Celsius. Sorry, degrees to radius, right? Those are measures of angles, and that's it. And I mean, if you don't understand any of this, don't worry. These are mostly math concepts, and yeah, so for the most parts of in this course and in future videos, we're gonna be mostly focusing on um, the random thing, and also the rounding and the random. So that's what we're gonna be focusing on. Just have this for reference purposes. Okay, so in the next video, I'm going to talk about another built-in method, and that is going to be the date method. And this is also very useful because it helps you to manipulate dates, which is very important. Imagine when you want to build things like countdowns. So you need the date object. You basically manipulate the date object to produce things like that, like event countdowns. Maybe you've seen event pages where you have this countdown that counts from that counts down to the date of the event, right? And it keeps reducing as we approach the date of the event until after the event, probably the countdown stops. So that is achieved using the built-in date object, and we're going to see that in the next video.